Today's lesson is using the slope formula to find the slope of a line. So let's look to see what the slope formula is. The slope of a line, if you look at the top of the slide here, is where you subtract the y's on the top and the x's on the bottom. Slope of a line is rise over run, and rise refers to the y-axis and run refers to the x-axis. It's rise over run. Here's where people get confused. When we're doing an ordered pair, you always, when you're graphing an ordered pair, you always start with the x and you do it first, and then, so you go across left or right first, and then you go up or down second. When you're graphing, you go left or right first, and then up or down second. But when you're figuring out the slope of the line, it's rise over run. So you have to think the rise, the y's first. So it's kind of the opposite of the way you're used to thinking. So what you need to do is have two ordered pairs. As long as you have two ordered pairs, then you have two x coordinates and two y coordinates. You need to subtract the y's on top. Now in the slope formula, it says y2 minus y1, x2 minus x1. And then some people have the question, well, how do you know which one's x2? How do you know x1? It doesn't matter which one is y1, doesn't matter which one's y2, as long as you keep it consistent. So what I like to say to myself is just subtract the y's on the top and the x's on the bottom. So in this particular problem, we have two ordered pairs. Okay, that means we have two x's and two y's, and we want to subtract the y's on the top. So the y's are the -3 and the -5. So which one do I write first? It doesn't matter. I'm going to show you that you can do both and you're going to end up with the same answer. So let's say we take the -3 as the y2, and we're going to subtract the other y. Now, when I subtract the x's on the bottom, I have to make sure, since I did the -3 first on the top, I have to do the 0 first on the bottom, so it would be 0 minus 5. So here we have two negatives that become a huge positive. So -3 plus a positive 5 is 2, and 0 minus 5 is -5. So the slope is -2/5. So what would have happened, let me just show you that it doesn't matter which one goes first. What would have happened if we would have had this one as the y2, and I would have said -5 minus a -3. And this time, since I did the -5 first, I have to put the 5 first for the x's. 5 minus 0. Do our giant plus sign, we have -2/5. You end up with the same slope. So just decide which one you want to put first and keep it consistent. So this, we can prove it by graphing this over here. If we were to graph the ordered pairs 0, -3, it would be right here. And if we were to graph 5, -5, it would be right here. So if you look at the slope, which is rise over run, we rise 2, a positive 2. We go to the left, a -5. Rise over run would be 2 over a -5, which is -2/5. So we can prove it there by doing that indeed is the slope, using the slope formula. There it is with all the animation. Now that is what we call a negative slope because it was a -2/5. And a negative slope, you will notice, is always going to go downhill. Okay, let's do the same thing. Let's just try it again. We're going to subtract the y's on the top and the x's on the bottom, so I can decide which one I want to do first. Both of the y's are -2, so it doesn't matter how we set this one up. It's going to be -2 minus a -2. Then I'm going to do the 7 minus a -2. Each minus a negative becomes a giant plus sign. So when you do that, you have -2 plus a positive 2, which is 0 on the top, and 7 plus 2, which is 9 on the bottom. 0 divided by 9. 0 divided by any number is 0. So we call this a zero slope. So let's look what a zero slope looks like. If we were to graph these two ordered pairs, here's negative 2, negative 2. Here is 7, negative 2. Notice that it is a horizontal line. So I think of this like when you're skiing. I call it a zero slope. This is like the greens on where you're just cross-country skiing on flat land and it's really hard. No slope. You're just cross-country skiing. So a zero slope is a horizontal line. Okay, let's try it again. Subtract the y's on the top, on the x's on the bottom. So when I set this up, I decided to put this 2 first, 2 minus a negative 2. So when I set up the x's, I have to do the negative 1 minus 4. Subtract the y's on the top and the x's on the bottom. This becomes a giant plus sign. So on top, I have 2 plus 2, and on the bottom, I have negative 1 plus a negative 4, which would be a negative 4/5 when you add it together. So our slope is a negative 4/5. So let's see what that looks like when we graph it. Another negative slope, so we know it's going to go downhill. Here is the ordered pair 4, 2. Here is the ordered pair negative 1, 2. Here's our line. And if you notice, we went down 4, so that would be a negative 4. And we went to the right 5, which is a positive 5. So rise, over, run, and one of them was negative. You could also do your arrows the opposite way. You could start with this ordered pair, and you could go up a positive 4, and to the left a negative 5. This time you have 4 over negative 5, but that's still a negative 4/5 because there's one negative. Subtracting the y's on the top and the x's on the bottom is the slope formula. Now this can come in handy when you have a table and you want to figure out the slope or the rate of change. Here is a table and we have 4 ordered pairs. We have the ordered pair 0, 1, 2, 5, 5, 11, and 6, 13. Now in order to use the slope formula, we only need to choose 2 points. And there are 4 of them. So which 2 do you choose? Again, it doesn't matter. You're going to get the same answer as long as this is a linear equation and a linear function. So let's say we just pick the first 2 ordered pairs. And we want to subtract the y's on the top. That would be 5 minus 1. Then we want to subtract the x's on the bottom, which would be 2 minus 0. That would give us 4 divided by 2, which is 2. A slope of 2, or you could call that a slope of 2 over 1 so that you can have a rise and a run. Now if I had chosen a different pair, let's say I would have chosen the last 2, then I would have had 13 minus 11, and I would have had 6 minus 5, and I would have had 2 divided by 1, same slope. So as long as it's a linear function, it doesn't matter which 2 points that you choose, you're still going to have the same slope. So on my animation here, I chose the first 2 and got that slope of 2. You have to realize that when you have a slope of 2, it's like having a slope of 2 over 1. Rise of 2, run of 1. So if you were to graph all 4 of these points, they're going to go way off. You'll notice that here we have a rise of 5 and a run of, that's supposed to be, what is that? 4, 2. Oh, that's the 4, 2. So that was a rise of 4 and a run of 2, which of course simplifies, because if I would have had another point in there, it would have been 2 over 1. It may not be a simplified fraction there. That one wasn't simplified, but it still equals the same thing. Okay, another practice. Here's a table, 4 ordered pairs. I can choose any of the 2 that I would like to. In this example, I'm just going to choose the first 2. 0 minus 3 for the y's. 0 minus a negative 2 for the x's. I subtract the y's on the top and the x's on the bottom. So on the top I have 0 minus 3, which is a negative 3. And I have 0 plus 2, which is a positive 2. So our slope is negative 3/2. If I were to graph these four ordered pairs, here's two of them. You see that we're going down 3 and to the right 2. That is negative 3/2 slope. This graph shows how much water is in a reservoir at different times. Find the slope of the line, then tell what the slope represents. So when you have a graph like this, it's always important to, first of all, let's see what the x or the domain is. It represents time. The range or the y-axis is height. So this is going to be the height of the water in the reservoir over a given amount of time. Now, on this particular line, I designated to you 2 points to look at. If their points are not there, then what you have to look for is where a line crosses an intersection. Always look for where a line crosses an intersection, and those would be 2 good points to choose. I chose those 2 for you. This one crossed right here at the intersection, and this one did too. So first we need to identify the 2 order pairs here. So for this right here, for the order pair, remember an order pair is x first and then y. So the x down here on the domain is 20. So 20 is the x on the domain. And then the y on the range is 3,000. So that order pair is 23,000. We go to the other point. The x is 60. And the range or the y-axis is 2,000. So we have 2 ordered pairs, and that's all we need to figure out the slope of a line. Now we're going to subtract. The y is on the top and the x is on the bottom. So I did 3,000 minus 2,000 on the top. And because the 3,000 was first, I have to put the 20 first on the bottom. So 20 minus 60 would give us 1,000 divided by negative 40, which is a negative 25. And remember that there's an invisible 1 down here. So we know our slope is a negative 25. So what does that mean? Well, because this is a negative slope, you can tell that the water in the reservoir is becoming less and less and less. And this slope means that for every hour, it's losing 25 centimeters. If you look over here at how it's labeled, 25 centimeters of water per hour. That seems like a lot. Down there it says cubic feet, and I don't know why that says cubic feet, because this says centimeters. Cubic centimeters. Okay, let's look at this one. A graph shows the height of a plant over a period of days. Find the slope of the line. So here again is the passage of time on the x-axis or the domain, and on the y-axis we have the height of the flower. This is a positive slope, so it's going uphill. So that immediately tells us that this plant is growing and getting taller. Again, you want to find either where the line crosses at an intersection, or in this particular example, they're actually given to you. This looks like a really good intersection right here, which was 50-20, as indicated way up here. This one is not at a good intersection, but it's given to you. It's 30-10. So we have 2, so we're going to subtract the y's on the top, which would be 20 minus 10. Because the 20 was first, we're going to subtract 50 minus 30 on the bottom. That would be 10 divided by 20, which is 1/2. So what does that mean? It means that the height of the plant is increasing at a rate of 1 centimeter, because that is the rise, was 1 centimeter. The rise is the range every 2 days. This is the run, the 2 is the run, and the run is the domain. 1 centimeter every 2 days. So rise over run. Find the slope from an equation. Creating 2 order pairs by finding the x and y intercepts. Now, in our last lesson, we were finding x and y intercepts, and we've discovered that in order to find the x and y intercept, all we have to do is plug in 0 to the opposite coordinate. So to find the y-intercept, what we want to do is we want to plug 0 into x. So 0 is plugged into the x. So when we solve that, 6 times 0 minus 5y equals 30. That would give us, so first we're going to move the 6 times 0 is just 0. It goes away. That's the really nice thing about finding these intercepts when it's in standard form. That goes away, and we simply have 30 divided by negative 5, which is negative 6. So y equals negative 6, and we plugged 0 into x. So here is one intercept. In order to figure out the x-intercept, we're going to plug 0 into y. Here's what it looks like when you plug in 0 to y. Now, the nice thing of it being in standard form, this goes away because that becomes 0. So you're just left with 6x equals 30, which means that x equals 5. X equals 5, and we plugged 0 into y. So here are our two-order pairs. Now we can use those two-order pairs to do our slope formula. We can subtract the y's on the top. I'm going to erase this and do it in red so it'll show it better. Here are our y's, was a negative 6 and a 0. So we're going to subtract those on the top and the x's on the bottom in the same order. Negative 6 minus 0 is negative 6, and 0 minus negative 5 is negative 5. We have learned when dividing with two negatives, it becomes a positive. So it's actually a positive 6/5, which is a positive slope. And if I were to graph those two intercepts and do a line, you would see that we could rise 6 and we go to the right 5, which is a slope of 6/5. Let's try that again. First, we're going to find the y-intercept by plugging 0 into x. That gives us 2 times 0 plus 3y equals 12. Since it's in standard form, this goes away, and it's really easy because it's just 3y equals 12. So our y is going to be equal to 4, and of course x was 0. So our y-intercept is 0, 4. For the x-intercept, we plug 0 into y. 3 times 0 is 0. That leaves us 2x equals 12, and x is equal to 6, and of course y was 0. If we were to subtract the y's on the top, that would be 4 minus 0 on the top, and 0 minus 6 on the bottom, which gives us a negative 4/6, or a simplified negative 2/3. And if you look over here, there is our y-intercept. Here's our x-intercept. You go down 4 to the right 6. That is a slope of negative 4/6 that were simplified to 2/3. So that is a lesson on finding the slope of the line using the slope formula.